Hello, my name is Rishi and today I will be using the biblioshiny bibliometric software to perform a bibliometric analysis on data exported from the Scopus database. Bibliometric analysis is a popular and rigorous method for exploring and analyzing large volumes of scientific data. It enables us to unpack the evolutionary nuances of a specific field while shedding light on the emerging areas in that field. biblioshiny is a bibliometric software that is suitable for non-coders as it focuses entirely on data analysis without having to write tedious code for it. It can be operated through the R programming language and works in a window in your internet browser. My topic of analysis will be the usage of machine learning in business analytics. I have chosen this topic because of my interest in machine learning and how it goes hand in hand with business intelligence. It can be used to bridge the gap in business intelligence tools because it can perform important analysis and adapt to different data sets. The research articles and journals for the same will now be extracted from the Scopus database in the BibTeX format. We will start by opening the Scopus database and typing machine learning in business analytics into the search bar. This gives us 1585 document results, but to make the data more relevant, we will be taking only those articles that pertain to the subject area of business and management, and the rest would be excluded. For this, we go in the filters and choose the subject area as business management and accounting. This results in 246 documents that will be chosen for our bibliometric analysis. Now we will export the same and load it into biblioshiny to start an analysis. biblioshiny can be started by typing the following code into RStudio and running it. It will open in a tab in our internet browser. We can load the data into biblioshiny by clicking on load data, choosing the file as a raw file. The database should be chosen as scopus, and now we can browse our computer to choose the bibtex file. In an overview, we can look at the main information, which will be presented to us in the form of a plot as well as a table, which gives us key information such as the number of documents that are considered, the annual growth rate, the average age of the document, the average citations per document, among other information. The first data visualization pattern that we are going to be seeing in biblioshiny is the word cloud. A word cloud, also known as a tag cloud or a text cloud, is a visual representation of a text in which the words appear bigger the more often they are mentioned. Word clouds are great for visualizing unstructured text data and getting insights on trends and patterns. Now I will show you how to view a word cloud in biblioshiny. Here we can see the word cloud for our exported dataset in biblioshiny, and looking at the size of the words, we can infer that keywords such as predictive analysis, machine learning, data analytics, and learning systems were the ones that were seen most in the articles, while words such as natural language processing systems, Internet of Things, and information use did not see much use in the articles. Now we will be moving on to the thematic map. The aim of conducting a thematic map is to gain insight into the field's current status and what its future sustainability holds. This analysis is useful in providing knowledge to researchers and stakeholders regarding the potentials of future research development of thematic areas within a field. We can view a thematic map in biblioshiny by going to conceptual structures and clicking on thematic map. Thematic map is thus obtained in biblioshiny, which divides the themes in the data set into four parts, which would be niche themes, motor themes, emerging or declining themes, and basic themes. Here we see that the motor themes include keywords such as machine learning, business processes, supply chain management, and cluster analysis. And basic themes include metadata and business decisions. The emerging and declining themes include intelligence systems, computer software, and data streams, while the niche systems include digital technologies in healthcare and cognitive computing. Now we will move on to the graphical representation of the frequency of words over time. This graph shows us the frequency of words in every single year of the analysis, which lets us see the trends and patterns in the analysis. We can see that predictive analysis was the most used word in 2012, which was overtaken by learning systems in 2017, which was finally overtaken by machine learning in 2022. Finally, we will see the plot of trend topics, which allows us to see what was the trend in every single year of the analysis. From here we can see that in 2020, the trend was predictive analytics, forecasting, and information management, which transitioned into decision making, machine learning, and data analytics for 2021. And for 2022, the trend is machine learning. To conclude, from the thematic map, we can see that the motor themes in the analysis include learning systems, data analytics, and information management, while cognitive computing and administrative data processing are niche themes. The word cloud shows us that the most used words in the analysis are data analytics, machine learning, and learning systems. Other noticeable words with high frequencies include big data and data mining. The graphical representation of the frequency of words over time shows us that the predictive analysis was the most common keyword in the beginning of the analysis, but it was overtaken by learning systems in 2017 and finally surpassed by data analytics at the end of the analysis time period. The plot of trend topics shows us that the emerging trends in the field have been predictive analysis, data analytics, and machine learning and decision making in the last few years of the analysis period. From this, we can conclude that the field of machine learning in business analytics is currently dominated by learning systems, data analytics, and information management. But in the future, we could see niche fields such as cognitive computing and administrative data processing emerge. Thank you.